Alright, grade 11s, let's look at paper 2, mathematical literacy. Pre-exam for 2025, out of 100 marks, and duration of 2 hours. Okay, let's go straight to question number 1. Question number 1, it says, Fatima plans to build a 2-bedroomed house in Mongwes. The diagram below is a floor plan of the house. Let's look at it. That is it. Okay, let's look at the question straight away. Write down the number of windows that are on the northern side of the house. Let's check the addendum. The northern part of the house. Now, when you look at the compass, it shows, the compass shows what? North. Meaning this is the northern side. That means this is the eastern side. Then this is the western side. And definitely this is the southern side. How did I get this? I looked at the compass. So now on the northern side, they have asked us how many windows we have. 1, okay, 2, and we have 3. So our answer here has to be, our answer here is what? 3 windows. 3 windows. Okay. Name one item in the bathroom. Name one item in the bathroom. This is the bathroom. What items do you see? We have item 1, item 2, 3, and 4. They said mention one of these. So we have a toilet seat or toilet. Then you have the basin or the sink. You have the bathtub, or you can call it the tub, and the shower. So mention any of those. Okay, one of them. Determine the number of single doors shown on the floor plan. Let's go to the floor plan and we see. When we look at the floor plan, we are looking for single doors. Let's count them. We say 1, we have 2, 3, 4, 5, 6, 7, 8, 9, we have 10. So there are 10 single doors. This we can't count it. This is a double door. This almost looks like a double door, but it's different. So we have 10. We have 10 single doors. All right. They're telling us the probability of selecting a bedroom in the floor plan in the floor plan above is 0.25. Express the probability as a simplified common fraction. Common fraction meaning the numerator is smaller than the denominator. However, when it's 0.25, what do we do? Let's make it in the form of what? Percentages already. So this is the same as this, but they said simplified. So by 25, you remain with 1. And by 25, you get a 4. If you don't know what to do, please come pick your calculator. Click on your calculator there. You press this there. It said 0.25 and you press equals. It will give you the answer as 1.4. This is what we want. 2 marks. Okay. Then let's continue. Fatima calculated the area of bedroom 1 to be 187,200 centimeters squared. Calculate the correct option from below that can convert. Now we are changing centimeters to meters. We are going to do what? We are dividing by 100. However, it's centimeter squared. Change it to meter squared. So we divide by 100 squared. So the only answer here is what? B. 100 squared. 100. This is why I'm choosing 100 squared. It's 100 times 100. Okay. We go on and we look at question number 1.2. 1.2. Yeah, this is the next year. 1.2 states that the list of ingredients for butter bean curry with chicken as made by Fatima is shown below. All right. These are the ingredients. The items are going to be used. Okay, there we go. They're telling us, calculate in grams the mass of the butter beans needed for this recipe. So the mass needed. So the butter beans, where are they? They're telling us 2 cans. But each can has a weight of 250. Each can has a weight of 250. What are we going to do? Since there are 2 cans, we shall come here and we say 2 times 250. And this will give us 500. But don't forget, these are what? Grams. Paper 2, please don't forget the units. You never know when they will be needed. A tablespoon is 3 times the quantity of a teaspoon. Determine how many mils is 1 tablespoon. Now, teaspoon is 5. So they are telling you it's 3 times a teaspoon, meaning 15 mil. Okay. Write down the minimum number of chicken pieces needed for this recipe. Minimum pieces of chicken. Now, when you come here, we have pieces of chicken at 8 to 10. Minimum 8. 8 what? Pieces. According to the instructions, this dish should take a maximum of 35 minutes to make. A client walks into a restaurant and orders the meal at the time indicated on clock A. Determine at what time will the meal be, or will the meal what time should the meal be ready? All right. So what are we going to do? Clock A, it's this one here. This is the time displayed, which is 9:45. What we do, we are adding 35 minutes. So this and that, you get a 0. You carry 1 here. So now 9:45 carry 0. This becomes how is it called? This is 80. When you get, because this is 1 plus 4, 5, 5 plus 8. But you can't have 80 minutes. That means it's 20 this side, and the 60 turn into the hour. But then, if you don't know how to do this, please, another person would have said, this is 45. How many minutes are remaining to make it 10? 15. That means we add 15 here, and you get the answer as what? 10. But this 15 is coming from the 35 minutes that are for preparation. Now, of 35 minutes, if you remove 15, what do you mean with 20 minutes? So the 20 minutes are added onto this. This is adding. Still, we get 10, 10, 20. Someone else who doesn't know how to do it, pick your calculator there. Guess what you're going to do? You say 9, press this key, 45, press that key, plus 0, press that key, 35 minutes, press that key, press equals. It's the answer. Look at that answer there. And this answer that you have here. That's how we do it, simply. Okay. Identify the type of the time format indicated in clock B. This one we call it digital, and this is called what? Analog. So in B, it's what? It's analog. And this brings us to the end of question number 1. Let's look at question number 2. Question number 2. Fatima bought a new cell phone. She wants to insert the SIM card into the phone. She must study the image with steps given below, showing how to insert a SIM card into a cell phone. So now what you have to take note, the steps are shown in the circles. Please don't mind about the phone, the name of the phone, whether it's an iPhone or what, it doesn't matter. We are looking at what they're telling us to do. Step number 1, we are only mentioning what is in the circles. Okay, so we go on. They're asking us, how many SIM cards can the cell phone shown above accommodate? Look here. This, it shows SIM 1. And when you look here, you have the micro SD, which is a memory card, and SIM 2. So how many are they? We shall say 2. Okay, write down the description of each step in your own words, please, in your own words. Don't make sentences, don't make paragraphs. Simple statements. For example, what do you see in step number 1? Step number 1, you can say, remove the what? The back cover of the phone. What do you see? By the way, remove the cover of the phone because the front is the screen, not the back cover. Remove the cover of the phone. Remove the cover of the phone. That's step number 1. Step number 2, what would you see? They are telling you, insert SIM 1. Nothing much, nothing less. Insert SIM 1 into the phone. Then here, what do we see in step number 2? Oh, sorry, the final step, it's what are we inserting? We are inserting both. Insert both the memory card and SIM 2. Definitely, you have to put the cover back and you switch it on and you continue. Those are the steps in simple instructions. Okay, then when we go ahead and we look at this, it says 2.1.3. Mention 2 advantages of using a cell phone with dual SIM option. 1, instead of carrying two devices, you carry what? You carry one. It's 2 in 1. So meaning you reduce on the weight, you reduce on chances of being targeted by thieves. It's one phone. Okay, number 2, we look at if one SIM slot gets faulty, you can easily use the other one. That's another thing. What else? You can have more than one network to use to deal with. You understand? Because when we deal with our networks, one is cheap, the other is expensive, depending on the condition. So if you have 2 in 1, you choose which one to use for calls, which one to use for data, because they are different rates. Okay, let's continue. Question number 2.2, we have a map there. We look at it nicely and we see what's happening. Anyway, and the questions are, identify the type of scale used on the map. The scale, it's this one here. So this is what we call the line scale or a linear scale. So I will call it a linear scale. Okay. Use the given scale to determine the distance as the crown flies in kilometers between Kimberley and Peter Mountain. Now, when we say as a crown or as a crow flies, please, this means it's a straight line, no jiggering. You understand? But they're saying as the crow flies from Kimberley here, as it flies from here to Petermaritzburg, Kimberley to Petermaritzburg. Here. What's the distance between these two? That's what we do. So you put your ruler here and you measure it. When I measured using mine, I got 5 centimeters. or, and you're saying what? 5 centimeters, or I got 50 mils. Now, remember they're saying you scale determine the distance in kilometers. In other words, they want you to have what? Actual distance. When you hear actual distance, what has to come in your head is to use a what? A scale. So what we do, we go back here, we measure from, now we are in kilometers, so from here to here. You see that? From here to there, I measured it and it was around it was around 24 millimeters when I put a ruler here up to here. So I got 24 millimeters. So now the distance I measured is 50 millimeters. I would stick to that. Okay. Let me do it this way. So we are turning the distance. Now I measure the distance on my map as 50 millimeters. So having measured this, I want it to become actual. Actual what? Distance. What am I going to use? I need to call on the scale. How will I call on the scale? Now, since I've measured 24 millimeters, meaning from here to there, if it's 24 millimeters on paper, in real life it's 125 kilometers. So I'll say 24 millimeters equivalent to 125 what? Kilometers. But in real on paper I measured 50 millimeters. You ask yourself, what will it be? What do I do? I cross multiply, which became 50 times 125 divided by 24. Do that for me. Let's do that. So we have 50, yes, times 125, okay, equals, and divided by 24. So the answer is 260, 4, 6. These are kilometers. Okay, 4 marks. 4 marks, 4 marks, 4 marks. Anyway, the actual distance between Kimberley and Petermarsburg via N12 and N1 is 805.7 kilometers. Fatima traveled from Kimberley to Petermarsburg to visit a friend. She left time for leaving. She left at 5:45 a.m. and arrived at 2 in Petermarsburg. Remember, Fatima, she was from Kimberley to Petermarsburg. She left, that's a duration, okay? Then she made 2 stops of 30 minutes each, meaning an hour resting. Now they're asking you, determine in hours. Determine in hours. So determine the time in hours. Fatima took driving, excluding the stoppage time, which is the time for breaks. So first and foremost, you're going to say, when we're looking at this, we're looking at duration, which is end time minus the time when it what? It started. So it ended at 2. Yet it began at 5:45. How much time is in between there? Those who did mathematics, you can see that now this is 15 minutes. Why? I can't subtract 45 from this, so I bring a 60 here. 60 minus 45, you get 15. Here you're left with 13. 13 minus 5, you remain with what? 8. However, we subtract the 30 minutes and there are 2 30 minutes, which is 1 hour. So the final answer becomes what? 7 minutes. Sorry, 7 hours, 15 minutes. The minutes have to change to hours because the answer is needed in what? Hours. How do you change minutes to hours? We divide by 60. So this became that divided by 60. Add this up. which became 7.25. These are hours. Don't hesitate to pause the video and you rewatch it of what I'm expecting. Sorry, of what I'm explaining. Okay. The other part that you would have done, it's here. You say 2 minus what? 5, 545. You press equals. You see that? It's 851. Minus what? 1. It became 715. Then you press this, which is 725. Remember, these are hours. 7, you see, the answer you have here, the same as the one that we've just calculated. All right, let's continue and we see what happens next. Okay, part B. Hence, calculate the average speed. Remember, average speed equals distance over time. And we've already got our distance. They told us it was 805 kilometers. 805 kilometers. 805,7. So we shall say 805,7 divided by 7,25. 7,25. Let's pick that and see what happens. So it's 805,7 divided by 7,25 equals. So it's 111, 13. Don't forget these are kilometers per hour. Okay, there we go. 2.2.4. Fatima drives a Toyota Corolla with a fuel consumption rate of 5.6 liters per 100 kilometers. Calculate the amount of fuel that will be needed for a return trip. Remember, we got the distance as this much. So the return trip we multiply by 2. So what is the total distance that we are looking at? Come, you say 805, 7 times 2. It becomes 1,611,4. This is the distance. But they have told you for every 100. So we divide by 100. Every 100, it takes 5.6. See that? So we divide this by 100. 16, times 5.6. It's 90, 23 or 24 liters. What did they say? They say round off? No. So that is calculate the amount of fuel. This is what they need for a return trip. That marks the end of question number 2, and we come to question number 3. Okay. Nemo bought lunch from Pizza Hut. Pizza Hut has a radius, okay? The pizza she bought has a radius of 200 millimeters. It was cut into 8 equal slices and served in a square box, as shown on the diagram. Okay, we will continue. They're telling us, define the term circumference. Circumference is the same as what? Perimeter. However, circumference is a total distance as the perimeter. Total distance around circular what? circular shapes. Circular shapes. Circumference. Anyway, calculate in centimeters squared the area of the pizza box. The area of the pizza box. Now, the area of the pizza box, they told it's a what? A square. The measurements are already here. So meaning the square, so the area will become 42 times 42, which becomes 42 times 42, 1,764 centimeters. What? Don't forget the units, please. Okay. Show that the area of the pizza is 71.25% of the area of the pizza box. That means we are going to get the area of the pizza over the area of the box, and we multiply by 100. Why? Because we are proving, this is what we are proving is what? A percentage. So we shall say area of the pizza, area of the pizza, so area of the pizza will be, let me write it here, area of the pizza, it's pi r squared. So it becomes 3,142 times, what is the radius? Remember the question says, talks of the diameter, the radius of this, but it's supposed to be in centimeters squared. So you divide by 10 and the answer becomes what? So we are saying we have to find the area of the pizza, which is already they have given the radius here, but the radius has to be in the same measurements as, or same units as those of the box. So what we do, we've already changed them and became 20. So it's 20 squared. We are looking for the area of the pizza. So having done that, you say 3142, 3142, 3,142 times 20 squared. You end up having, remember we are proving that this area here is 71% of the area of the square box. All right, so we've got this area here. It's already centimeters what? Squared. Look at the values only. So we are going to say the area of the pizza, which is 1,256,8 divided by the area of the box multiplied with 100. Multiply with 100. So we shall come down there and we see we are proving, we are proving this here. Ne? We are saying the area of the pizza 156,8 divided by this 1764 times 100. Indeed, the answer became 70. Actually, they are saying show that. So you've showed. Okay. Determine the area of one slice of pizza. Area of one slice of pizza. Now remember we found out that the area of the pizza, it's this much. Together? And they are telling you there are 8 equal slices. Meaning we're going to get the area of only one pizza, which is 1,256,8. We divide it by 8. Divide that by 8. And the answer became 175 centimeters what? Square. Okay. That marks the end. Sorry, that's a question there. Then we come to 30.1.4. 30.1.4. 30.1.5. Calculate the total surface area of the pizza box if the box has a height of 30.5 centimeters. And they're telling you may use the total, which is fine. So they're telling you 2 into the area of the pizza that we've just seen as area of the pizza box. We saw it as 1,700 and what? 764 plus 4 into what's the side? The side they told us it was 24 centimeters. Isn't it? Or 42, sorry. It was 42. Thank you. So we shall put 42 here times the height, which is 3.5. So we do that, we multiply. Actually, at this moment, you just pick your calculator there. You do it. It's 2 open brackets 1764 close the brackets plus 4 open brackets 42 times 3.15. Sorry, 3.5. So the answer becomes 4,116. Don't forget the units. Centimeters what? Squared. Centimeters squared. All right, 3.1.6. It says, now asked one of the employees of the Pizza Hut about the temperature used to bake the pizza. She was told that the pizza is baked at 25 degrees Celsius. Convert the temperature to Fahrenheit, to F, and they have already given the formula. Simple. What you're going to do is say that 9 out of 5 times 250, close the brackets, plus. So we do that and we see it's 9 over 5 times 250 plus 32. 400 and that degrees, but now they have become that Fahrenheit. Okay. 3.2.1, write down the health risk of an individual with a BMI of 35 kilograms per meter squared. Health risk, so health risk is this one here. A person is this, so the BMI is there, so it's already above this. Sorry, above this. 35, it's in between this, it's obese. So health risk is what? High. Are we there? So calculate Neo's BMI rounded off to 2 decimal places if the height is 1.8 meters tall and the weight is 7.75 kilograms. Substitute in the formula 75 divided by 1.8, but don't forget it's supposed to be squared. So the answer here becomes 75 over 1.2 squared. So the answer is 32, 23, sorry, 15. Don't forget the units. So they said, that is it. Oh, comment on her status, weight status. 23, 23, 23 is in between this. It's no more. It's 23.5, which is around here. So look at what she has. Okay. We continue and we see Neo is worried about her friend whose is obese. Mention, please, here you mention ways of how to become healthy. Ways on how to cut weight. Please, ways on how to cut down on the weight. Ways. There are many, as long as you explain nicely. Okay, that marks the end of question number 3. Let's look at question number 4. Neo sells sets of constants for coffee, tea, and sugar. Table 1 below shows 2 options. Each constant lead is made of bamboo and is 1 centimeter thereof goes into the canister, meaning the height, because the lead has to take 1 centimeter off. So whatever you put in, it stops at the lead here. So that will be the height there. Anyway, let's come to question here and say 4.1. 4.1.1. Determine the height of the sugar in both types of constants. Now, the height of sugar. Good enough, both have the same heights. So all we need to do, we are going to reduce it by 1. Why by 1? Because the size of the lead, the height of the lead is 1. So it will be 13.7 minus 1, which gives us 12.7 centimeters. Okay. Then they're telling us, or they're asking us, determine the difference between the volume of sugar in cylindrical constant and the volume of sugar in the rectangular constant. Now, this one needs us to have a bit of space here. Let me use this one here. Remember, the difference between, the question says the difference between determine the difference between the volume of sugar in the cylindrical constant and the volume of sugar in the rectangular constant. So we are comparing volumes. So volume, I'll start with the cylindrical one. Volume over cylinder, it becomes pi r squared h. You see that? So we shall ask ourselves, what do we have in this scenario? The cylindrical one. What's the diameter? So we need r. So our r here is going to be 11.6 divided by 2, which became 4.8. Sorry, 5, this is the radius. So the volume will become 3.142 times 5, times the height. Remember the height of sugar that we've just got, so it becomes 12.7. Get the answer there, which is 1,342.35 centimeters, right? Cube. This is at the level of the cylinder. Then what about the level of the rectangular prism? Remember it says W times height. So the height of, or the length of, the length 1.5. Okay. So the length is 1.35. The width is 11. The height has become what? 12. Remember, we are looking at the volume of sugar, not the volume of the can. Put this in the calculator. What do you end up having? We are saying we have 0.35 times 11 times 12.7. Press equals. Okay, that was the difference. Okay. 4.1.3. Nemo decided to buy both types of scan stand to sell. She packed the scan stand in a box with dimensions as follows. Return the number of cylindrical can stands that can be packed in one box. What we're going to do is to look at what's happening to us. So in other words, there's a box. There is a big box there. And this box, they have to pack these can stands inside here. They have to pack the can stands inside here. We need to, first and foremost, we need to know how many will meet on the long side and how many will fit on the short side. That's the first thing we're going to do. So what we're going to do lengthwise, we call it lengthwise. We shall say lengthwise divided by the diameter. The diameter of only one can stand. So the diameter is already seen here as 11,6. So we shall come here, divide by 11,6. And we get the answer as 6. So meaning on the long side, we shall have 6 can stands. Then what about on the short side? Widthwise, which becomes 45 divided by the diameter, which becomes 3. Then the layers are going to be the height of the box, 27,5, divided by the height of only one can that we've seen up there. This one's the height is 13, 13, what? 7. You still get the answer there as what? 2. So only all this has 6 by 3 times 2. And the answer became 36. 36. Anyway, B. Neo claimed that she can pack more rectangular can stands than cylindrical can stand in one box if she packed them length to length. So now the story has changed. We are no longer packing cylindrical, but we are packing rectangular. So in the box that we might have there, they want to find out how many will fit on the long side and how many will fit on the short side. Anyway, what we're going to do, get the length of the box divided by the length of the can stand. That's the first thing, lengthwise. So we shall say the length of the box is 70 centimeters. Length of the can stand is 115, which gives us what? 6. Then this is on the long side, you have 6. What about the short side, which will become width of the box divided by the width of the can stand? So we shall say 45, that's the width of the box, divided by the width of the giving us 4. Then the layers, height of the box divided by the height of the seam of the can stand, which becomes height of the box two comma divided by 13,7. So in this scenario, what we got, this was a 2. And this is a 4. This is a 6. So when you get 6 times 4 times 2, you end up having 24 times 2, you get 48. So the claim is what? The claim is valid. They are more than. All right, let's look at 4.2, which marks the end of this question paper. It says, look at annexure E. Annexure E. Determine the total number of people who attended the concert. So remember, they said wherever they see a number, there's a person. So the easiest way to do it is create what we call a perfect rectangle or square. For example, here you see all they are filled up. Also from here, all of them are. So let's calculate that. That means we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 times 1, 2, 3, 4, 5. These ones are complete. So it's going to be 17 times 5. 17 times 5 plus what? Because the 5 have ended already. So plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. So we come and add them, 17, and the answer becomes 102 people. Write it down or write in simplified form the ratio of the total number of seats in section A to the total number of seats in the hall. Now, what are you going to do? The total number of seats. So these squares are all seats. So we have 1, 2, 3, 4, 5, 6, 7. So meaning it's going to be 7 times 17. The total population, 7 times 17, which is 119. So remember we're looking at simplified ratio, section A. So when you look at section A, you'll have 14 is to the whole number. Which is 4 is to 7.